here's our objective. All right. Here's our note sheet. And okay, now, first thing we need to talk about strong acids and strong bases. All right. These being all strong acids, list them out. These being all strong bases, here are some examples. One thing about these is all of these anions all right, and the same thing goes with here, along with like magnesium hydroxide and calcium hydroxide. These two are pH neutral, along with these three. They don't affect pH. These cations, these anions slash cations, are pH neutral. They're, okay, having said that, they will often be bonded with a conjugate acid or base of a weak base or weak acid, respectively. All right? And this will play out in a second, and I'll go over some examples. So, just to reiterate, your strong acid anions, these, are pH neutral. These anions are all neutral. They don't affect pH. And I'm talking about the sulfite, and on, or not, it's like by hydrogen bisulfate. These cations are also pH negative, pH neutral, and they don't affect pH. Then what that means is you're going to see them often as a bonded in a salt, and this is something like this: ammonium chloride. Ammonium is a weak acid. Chloride is a pH neutral anion. Therefore, this salt would be acidic. All right. Now, if you have a salt and you're unclear if it's an acid or a base, you're going to have to do a little bit of legwork and just be aware of a couple things. Your steps are to separate salt into ions, all right, and I'll go over this. Then you might need to write some equations if you're unsure, and you may need to compare your Ka and Kb. That's if you have like an acidic anion or cation and a basic anion. You'd have to compare those two values and then say, hey, which one's bigger? And that would tell you the solution. I'll go over the examples. All right. Let's say I had salt solution. Well, Na is an anion, is a cation that's often in with sodium hydroxide, lithium hydroxide. These are strong bases. Therefore, this is a pH neutral anion, cation. And it's the same thing here, chloride, HCl. So this is a neutral solution. Okay, iron chloride. We just went over, this is neutral. Iron is actually a acidic cation because it's a small, highly charged cation. This is acidic. So this solution would be acidic because of this. The cation is acidic. And what iron does is it forms a complex with water. and gets one of these daughters to donate one of its protons, that'd be a 5, H2O, OH negative, and then this is going to be plus 2 plus H3O plus. That's what it happens. All right, it basically donates, it gets water, it forms this complex and donate one of the water, tricks water into donating a proton to another water. That's how it becomes acidic. Okay, these small acidic ions are not part of the AP curriculum, so you don't need to know that. But in terms of thorough. All right, here we go. Now, this is methylamine chloride. I think I might be saying that. All right, here we go. Chances are, if it's with chlorine, which is the anion of a strong base, a strong acid, that this is probably going to also be one or the other. All right, so CH4 NH3, this would be plus, all right? Now, and this is chloride. If it's a plus, that means it's probably going to want to donate H to a different, and therefore act as an acid. It's a 2. Now, another thing, if I flip them, this can act as a base to make this. This has a Kb value. It's methylamine. Its Kb value, I could look it up in the book. Therefore, if this is acting as an an acid, this would be an acidic solution. That salt would be an acid, considered an acid. It would make an acidic solution because it donated a proton, and I confirmed it by looking, thinking about this as a base, and you could see it's the conjugate acid of that salt, or sorry, conjugate base of that salt. All right. All right. Here we go. Sodium phosphate. This is a neutral. Is phosphate going to be neutral, or is it going to be a basic? Are there any ways for this to accept protons or donate hydrogens? It can't donate hydrogens because it doesn't have any, but it could certainly accept a proton to make this, and it could do it 3 times and make eventually, phosphoric acid. If it's making this is a weak acid, and you don't have to have these memorized, you'd be given like a Ka value or some sort of, maybe you know it just from experience. If it can be turned into an acid, then it in itself, outside of my strong ones, make this solution a base, because it's the conjugate base of a weak acid. All right? Your conjugate bases of your weak acids are indeed bases themselves. Unlike the strong acids like HCl, plus water is going to get H plus and Cl negative, and I dropped the water, I'll put it there. This is not a base in the sense that it doesn't affect pH. It is the conjugate base of this in terms of the equation, but it doesn't affect the pH because it just doesn't. It's stable the way it is due to its electronegativity difference. Okay, last one. Now, this NH4, how do I, NH4 plus, how do I, what would it do? This is an acid, all right? It's the weak acid. You got to work backwards of ammonium, and it acts as an acid because ammonium can accept a proton and make this. So this is a base, and that's an acid. And then fluorine ion, what is that? Is fluorine an acid or a base? Well, it's negative, so it's probably going to accept a proton from a this. So if it's accepting a proton, it's a base. Now, but they're both, so this is acidic and this is basic. How am I going to figure out which one's stronger? Which one's going to give me influence the overall solution? All right, I'd have to look up their Ka and their Kb values. Let me do that. Okay, so here's the Ka value for hydrofluoric acid, and here's the Kb value for ammonium. But you're in truth comparing you want to know the Kb value of your fluoride and your Ka value for your ammonium. So for NH3, my Ka is going to be equal to my Kw divided by my Kb. So 1 times 10 to the negative 14th divided by 1.76 10 to the negative 5. And that's going to give me, all right, my Ka is this. That's for NH4 plus, okay? Now, for H, I want to know my Kb value for F. So Kb is going to be Kw divided by Ka of, so 1 times 10 to the negative 14th divided by 6.8 times 10 to the negative 4th. All right? My Ka is 1.47 times 10 to the negative 11th. Okay, which one's bigger? My Ka value, so this is Kb, my Ka value is bigger of this, therefore the solution would be acidic. Ka is bigger than Kb, acidic. Okay, oh, I didn't write. Ka is bigger than the Kb, so it's acidic.